So the basic idea here is that we have a new form for a quadratic equation. So whereas in the past we've identified a quadratic function by this form, f of x equals ax squared plus bx plus c, we now have an equivalent form that's a different form, but it's equivalent, and that's the form a times x minus h squared plus k. The a here is the same as the a here. The h and the k actually come from doing a little bit of juggling around of these values over here, but that's not important for our purposes. What we want you to know is that this is our new standard form for a quadratic function, can be expressed in this form, and you do that by completing the square. And so a lot of the practice in here is practice with completing the square. The reason that this form is attractive is because that h and that k are the coordinates of the vertex of the parabola, and the value of a tells us whether the parabola is an opening upward or downward parabola. So if a is greater than 0, we have a parabola that opens upward, and if a is less than 0, we have a parabola that opens downward. So this is a handy form, and to practice expressing quadratics in that form, we practice doing this problem, and so we see that we have a equals 1 here, so we can just proceed by grouping together x squared plus 4x, and then we'll determine what we need to add here in order to make a complete square. We'll just keep the plus 3 out of the question. We'll just leave that right out there. So to figure out what we need to add, we examine this 4, and we take that number, 4 divided by 2, and square. 4 divided by 2 is 2. 2 squared is 4, so 4 is the number we add. Now we have to compensate for the fact that we added 4 by subtracting 4. So if you were to work all this out here in this entire row, you should be able to get back to x squared plus 4x plus 3. But now we have our our quadratic function in this form. X plus 2 squared is what's in parentheses, and plus 3 minus 4 is minus 1. So now we know that the vertex is h, which is negative 2, and k, which is 1. So the reason why that happens is because over here, notice it's x minus h, so we here have x plus 2. So x plus 2 equals x minus h. So the x's cancel out, you get 2 equals minus h, and therefore minus 2 equals h. And then a similar process shows why the second coordinate k is positive 1. So there's your vertex. So you can sketch the graph because it's now easy to figure out what the x and y intercepts are. The x-intercepts, remember, are what you get when the function is equal to 0. So when this is equal to 0. So we take x plus 2 squared minus 1, set it equal to 0. And the easy way to do this is just to set the 1 on the other side. So you get x plus 2 squared equals 1. And now take the square root of both sides. You get x plus 2 equals plus or minus 1, because the square root of 1 is 1. And so you get negative 2 plus 1 and negative 2 minus 1. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. So those are the x-intercepts. And the y-intercept is what you get when x equals 0. So you can make x equals 0 here. When x equals 0, you can see y equals 3. So you have 0, 3. And then you have two x-intercepts. You have negative 1, 0, and you have negative 3, 0. So I'll leave it to you to sketch the graph. You have the vertex right here, the vertex. You have the y-intercept, and you have two x-intercepts. So you should be able to sketch the graph with that. In this section, among other things, your most important thing is being able to express quadratic functions in the standard form that lets you identify whether the parabola opens up or down, the graph being a parabola, whether it opens up or down, and also to see what the vertex is. So the A tells you whether the parabola opens up or down. Remember, if A is positive, the parabola opens up, and then that means that the vertex is down here, and the function value for the vertex, the y-coordinate, is a minimum value. But if a, so that's if a is greater than 0. If a is less than 0 or negative, then you have a maximum value. The parabola opens down. And so when the parabola equation is in this form, the vertex v is equal to the ordered pair, or has coordinates hk. So to find the vertex of the parabola when it's not in the standard form, you use a method of completing the square. And the trick that you do is to add 0 so that the square is complete. So for this particular quadratic, we have x squared plus 4x. We want to complete the square on the x squared plus 4x part. So we'll keep x squared plus 4x grouped together. And this plus 3 we'll just completely leave out of the square quadratic part. So this is still x squared plus 4x plus 3, but now we have to add. And we add 4, the middle term coefficient, divided by 2, squared. 4 divided by 2 is 2, 2 squared is 4. So we're adding 4. So we have to compensate for that by subtracting 4. So if you were to multiply all this out, you would get back to x squared plus 4x plus 3. But now our quadratic function is written in a form that allows us to recognize the vertex. And negative 3 plus 4 is minus 1. So the vertex now is, remember, hk. But remember, x minus h is x plus 2. So that means h is negative 2. And plus k here, we have a minus 1, so that means k is negative 1. So the vertex is negative 2, negative 1. So what we have here is a shift of the parabola x squared by 2 units to the left and then 1 unit down. So that's why it's so nice to have the function written in this standard form, because it makes it really easy to sketch the graph. And so when we sketch the graph, we know that we had this shift. Our new vertex is negative 2, negative 1. So if this is negative 2 and this is negative 1, we can plot the vertex. Now we want to find the x-intercept. So we take this and set that equal to 0. And that's how we always find x-intercepts, when y equals 0. Y is x plus 2 squared minus 1. Set that equal to 0. And so that means that we're going to have x plus 2 squared. X plus 2 squared equals 1. And now we take the square root of both sides. X plus 2 equals plus or minus 1, because the square root of 1 is 1. And so we get x equals negative 2 plus or minus 1. Negative 2 plus 1 is negative 1. And negative 2 minus 1 is negative 3. So we have x-intercepts at negative 1 and at negative 3. So there's negative 1, there's negative 3. So we have an x-intercept here, and we have an x-intercept there at negative 3. Now the y-intercept we get when x equals 0, and that's easy to find over here. When x equals 0, we get y equals 3. So 3 on the y-axis is the y-intercept. So we have that going there. And so the graph does something like this. It's y-intercept, x-intercept, vertex, x-intercept, like that. So there's the parabola. So again, when you have the parabola written in this standard form, it's easy to find what the maximum or minimum value is. The minimum value is k if a is greater than 0, because then you have a parabola that opens upward. And the maximum value is k if a is less than 0, because then you have a parabola that opens downward. So if we look at this first one here, f of x equals 3x squared minus 6x plus 1, we want to complete the square. The first step is to factor out that 3. So we get 3 times x squared minus 2x. And again, we're going to leave a space, and we're going to keep that other constant, that 1, right here. We're going to keep that completely out of the picture and not deal with it at all. Now we want to figure out what we have to add to complete the square here. We take negative 2 and divide by 2 and square that, so we're going to get 1, so we're going to add 1. But remember now, we have a 3 out here, and so that 3 tells us that we didn't really add 1, we really added 3. So to compensate for that, we have to subtract 3. Once again, if you multiplied all this stuff out, you would get back to your original function right here, 3x squared minus 6x plus 1. But we're not going to do that. Instead, we're going to show the factored form. This is 3 times x minus 1, quantity squared, and plus 1 minus 3 is minus 2. So now we have a vertical stretch of 3 with a shift to the right of 1 and down of 2. Okay, so what do we have? Do we have a maximum or a minimum? Well, here's your A. A is greater than 0. A is positive, means that the parabola opens upward, and that means that we have a minimum, and the minimum is -2. It occurs at the x value 1. When x equals 1, the minimum is -2. I will just get you started on the next one. For the next one, all you have to do is take this function, minus x squared minus 3x plus 3, and factor out that negative symbol. So you have a negative x squared plus 3x, and you're going to complete the square on that. And then this plus 3, leave that completely out of the picture. Just put it right out there. The only other difficulty on this is that this 3 is an odd number. So when you do 3 divide by 2 and then square, you're going to get 9/4. So you're going to add 9/4. But again, you have to remember that you didn't really add 9/4 because there's a negative right here with that 9/4. You really added negative 9/4. So to compensate for that, you're going to add positive 9/4. And then I'll let you finish the rest of that one. The next page, we have finding the maximum or minimum value using a different method, and that is if the quadratic function is in our nice other standard form that we had before, where we can recognize the constants a, b, and c, then we know that the maximum or minimum, whatever it is, occurs when x equals -b over 2a. And then, if a is greater than 0, it's a minimum, and it's f of -b over 2a. If a is less than 0, it's a maximum, which is f of -b over 2a. So in either case, you have to figure out -b over 2a, get that value, and then you have to do f of -b over 2a in either case. And then you'll have either a minimum or a maximum, depending on whether a is greater than 0 or less than 0. So if we look at this first one, f of x equals x squared plus x plus 1, and we think of completing the square on that, we have x squared plus x squared plus x, and then keep the other plus 1 completely out. Now the coefficient of x in there is 1, so 1/2 squared is 1/4. So we add 1/4. We actually did add 1/4, so now to compensate we subtract 1/4. And that gives us x plus 1/2 squared plus 1 minus 1/4, which is 3/4. And so that's by completing the square. But in this section, what we're doing is we're seeing how we can find the max or min by using this formula here. So let's see how we get the same thing. In this case, we want minus b over 2a. Well, b is 1, so we get -1 over 2 times a. A is 1, so 2 times 1, that's -1/2. Now we just have to do f of -1/2 to find the minimum value. We know it's a minimum because this coefficient is positive, so we know the graph opens up. By the way, this -1/2, that's your h right here. That's the x-coordinate of the vertex. So when we do f of -1/2, we get -1/2 squared plus -1/2 plus 1. Now you can work this out all the way for yourself, but I will tell you that you will get 3/4 when you're done. I know that for a fact because I know that's what the answer is because we did it the other way. So work that out. It's good practice to work those fractions out. Now, the next thing we did was this word problem on advertising. So I'm not going to go through this again. This is one where you just have to find the maximum effectiveness. Maximum effectiveness. So here's your equation. So just use minus b over 2a, find out what that is, and then do f of, or actually it would be e of minus b over 2a. There you have, and that's what you're going to have. So that's going to be the vertex. This will be the vertex. I'll put a v in the front. There's the x-coordinate, and there's the y-coordinate, and that's going to be your what? Well, a is negative, so that means the parabola opens down, so that's going to be your max. So you can work that one out. We did that extensively. And then the last one we did was the stadium revenue problem, which seemed to be a difficult problem for a lot of people, especially looking at the one that's similar to it that's assigned. So we wanted to find a function that models revenue. The revenue is equal to the number of tickets sold times the attendance, so the number of people who attend the game. Each person pays for a ticket, so you have to multiply times the attendance to figure out the total revenue. That's just the money you took in. So the number of tickets sold is what we don't know. We don't know what the new ticket price is going to be. So we'll let X be the new ticket price, the new reduced ticket price, because that's what they're doing. They're letting the ticket price go down. Okay? Now, we know that when the price was $10, they had an average attendance of 27,000. And so now we know that every dollar that they lower the price, the attendance actually goes up by 3,000 people. Well, if the old ticket price was $10 and the new ticket price is X dollars, then 10 minus X is the number of dollars, or the dollars in decrease, dollars that the ticket price went down. I'm going to use a little down arrow for decrease. So that's the number of dollars that the ticket price decreased. Now we know that for every dollar the ticket price decreases, they get 3,000 more people. So the attendance is going to go up by 3,000 times 10 minus X. And that's the amount the attendance is going to go up. Amount the attendance goes up. Amount attendance increases. Okay, that's because they lowered the ticket price. So now what's the new attendance going to be? Well, the attendance is going to increase by that amount from what value? Well, the attendance has been 27,000 at the $10 price. So we can assume that that average of 27,000 will now be exceeded by, so we're going to add to that, 3,000 times 10 minus X. And that's the revenue function. No, that's not the revenue function. That's the attendance. That's the new attendance, sorry. The new attendance. So the revenue function is the attendance times the number of tickets that are sold. And so finally, what we get for our revenue function is, we get the number of tickets sold, which is the same as the attendance. So that's 27,000 plus 3,000 times 10 minus X. Number of tickets sold times the ticket price. I think I have it wrong up here where I say revenue is number of tickets sold times attendance, because actually those are the same thing. So it shouldn't be number of tickets sold times attendance up here. It should be price of a ticket. Price per ticket. Price per ticket times attendance is revenue. And so the revenue is here, this attendance times the price per ticket, which is X. So X times that. So you want to maximize that function. Sorry about that mistake all the way at the beginning, but I just don't think I want to record this entire lesson over just to get one little error at the end fixed. So just bear with it. The beginning function R of X should have been price per ticket times attendance. That's your revenue. And so X is the new price per ticket. And then this is the attendance right here. And so you just multiply those two together to get the revenue.